All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada, your original Show and Tell host.
Correct.
Thanks to Liz and Melissa and JP and whoever else, I can't remember off the top of my head, who hosted Show and Tell last couple of weeks. We'll be doing the next few weeks, and then we'll cycle back again, so everyone gets a chance. Right now, for the next 25-ish minutes, we're going to check in with folks from around the maker community. What are you 3D printing, coding, hacking, roboting, sewing, whatever? We want to see it. Crafting. Come on by. We're in Discord. All are welcome. We're going to start off with Jay and his shoulder bot.
Jay, what you got going on this week?
Hey, Jay.
Hey, I just came to show off my newest little wearable robot. I've named him Digit, and it's a new wearable robot, which for the first time in my design life doesn't need a strap. Haha, no strap.
That's cool.
Cool.
Yeah, it's still a prototype, so it still has some issues here and there, which I'm trying to work out now. But it's using an Adafruit. Sorry, it's been a day for me. It's using an Arduino BLE sense with the accelerometer to actually get the head motion correct. So when I'm wearing it, it'll always look forward. So if I turn this way, the head will start.
Oh, that's nice.
That's a good idea.
Yeah, that way I can always kind of make it look good in pictures. That's always something that's been bothering me with my work, is when I do my robots, they kind of like lean too much. And when people take a picture of it later, I notice it and I'm like, it looks weird.
Yeah.
So I finally fixed two problems. I fixed the lean problem and I fixed the other problem with the GoPro stack. So don't need either of those two. This thing works pretty well right now. I'm working on the upgrade now that I can document it and of course, show the internet. But this is like the new one I'm slowly working on now, which will have another.
That's nice.
Ooh, cool.
But yeah, that's what I've been working on this past month. Has been just this.
Well,
does this robot have a name or a species name?
I call them Digit.
Digits?
Just Digits. Just
all right.
That works.
Nice.
All right, Jay. Well,
all right, Jay, Digit.
Keep coming back with progress. It's a cute robot.
It's very cute.
Good work.
I love the antennas.
Making robot friends, not robot enemies.
Oh, bye, Digit.
All right. Next up, here's a friend of the show who we actually know, and you all might know from a couple of things. Circuit Sculptures, but Particle. Speaking of, we're wearing Particle shirts. You have I know a lot of people at Particle. We all go way back, and you have a new product launch, and they said, "Come on by the show and tell." So you have M.T stuff, right, this week?
Yeah, absolutely.
Yeah, show it off.
Well, all right. So I'm going to switch my cameras here. So as you know, most of our Particle cellular-based products used Adafruit Feather. This is like the OG of our cellular devices. But what we saw was, we have been using U-Blocks modules for cellular devices. But when we switched over to Cocktail, the Cocktail modules are pretty big. And so we had to put them on a M.2 carrier board. And so this is our latest M-series. M can stand for many things, no pun intended, multi-radio, multi-ues. And so this particular series is multi-radio in a way where it has redundant connection between cellular and Wi-Fi. But it also has built-in GNSS receiver and Bluetooth. And so it's like a full-featured multi-radio SOM that is, very easy to use. And so in addition to using a M.2 series, now, this is not very easy to prototype because you can't really breadboard it. So, and we can't put it on a Feather form factor. So what could we do? So we came up with this idea where we designed a product called Muon, which is basically a carrier board for the M series. And so it breaks all the GPIOs into just female headers, has SWD connector, a stemma or quick connector over here, a 3-pin battery so that you can monitor the temperature of the battery, USB PD, actually not just USB-C. And so we are pretty excited because this will become our next generation dev kit. It's not breadboard friendly, but it's very prototype friendly. And so we have a series of expansion cards that we have been designing, proto cards, industrial cards. And so we're hoping that this allows people to go from, just developing prototypes to actually creating products. Just a side note, I created this little a sensor carrier board based on Adafruit. This is like pegboard friendly, so I can mount the entire thing on a pegboard, so I free up some disk space. We also created this little adapter plate. This is made out of just a PCB, but very simple, so that you can plug in your M-series M-song. And the cool thing is then you can plug this into our old Monitor 1 enclosure, which is fully IP67 rated. It has big chunky RF connectors, signal connectors, and so by just developing products on or prototyping on the new one, we take it into mass production fairly easily by just using these adapter plates. We also have a M-series breakout board, which actually uses an Adafruit Ethernet wing to provide even additional redundancy. So if the Ethernet fails, it fallbacks in Wi-Fi. If the Wi-Fi fails, it can go on to cellular, thus maintaining connectivity in harsh conditions. I don't have a sample, but there's also going to be an M635, which is a NTN, which is like based on satellite. And so that's our first foray into satellite connectivity, allowing people to then even have non-terrestrial networks in addition to having LTE Cat M1 or LTE Cat 1 or 2G, 3G fallback, or going further and using satellite. So pretty excited what people will do with satellite communications.
Yeah, that's cool. Can you flip the M module over? Is there something on the other side, or is it flat?
Oh yeah.
Okay.
No. So we have a so we have the actual cocktail module on the top, and on the back is the ARM Cortex M33 Realtek chipset, which is an RTL8722. That's the SoC. And so that's all.
Okay. All right. So I think that was actually it's like a Quectel, like whatever. Yeah. Okay.
Right.
Cool.
Depending upon which cellular.
Yeah. Okay, cool. No, because I was like, wow, how did you get it under 1 tin? And it's like, oh, there's 2 tins. Okay.
That's 2 tins. And it comes with embedded SIM, so you don't have to have any additional SIMs.
I love that M2 just made me think, I should really make a little M2 break.
Yeah, we've been waiting. We're like, well, when will there be stuff to make accessories for?
Yeah.
What are the modules that we'd want to use? So this is good timing.
Is this compatible with the SparkFun M2 pinout, or is this a different M2 pinout?
That's a proprietary particle pinout. SparkFun came afterwards. We were hoping maybe they could have reached out and we could have collaborated, but that never happened.
It was just like ships back. No, I mean, I don't care.
I think I had I put up something on GitHub with here's the M2 stuff that I started, and then COVID and chip shortage and stuff like that happened. Right. But just Stemma and Quick and all that, maybe when we take a look at it, we'll try to do our best to make it work with everything in some ways. Maybe we'll drop you a note when we're ready to do some designs.
Absolutely. And I would love, right now I'm working on, again, a little side project. I made this little gadget that fetches weather data and uses a Adafruit temperature humidity sensor, but I want to make this version with the M.2 module.
Yeah.
So you can easily add displays to the expansion cards. So most of the displays that you have are compatible with the particle ecosystem. Now imagine having a touch display on the top that is compatible with Nuon, and now you have a cellular connected display.
Right on. Well, keep coming back each week. You can come by with some circuit displays, come by with some new particle stuff. Always good to see you. And thanks for sharing online all of your creations. A lot of people are big fans of yours.
Thank you. Thank you so much.
Thanks, Mohit.
All right. That worked out great.
And congratulations on the new product launch.
Say hi to Zach and Artie for us. Okay. We'll go to Melissa, then Liz, and then we're going to go to Cinnamon, then Mark, and then DJ Devin, Nanographs. We got a lot of folks here.
Okay, a bunch of people came by.
So let's all speed round so we can get everybody in. Melissa, what you got going on?
Hi, I have something I kind of built over the weekend here. It's a Pi 1541. It's uses a Raspberry Pi 3A Plus in here, and it's running some code on here that's bare metal, so it actually boots pretty quickly. And I just wanted to show it off on this Commodore 64 here, so it can plug into either ports here. I'm going to go ahead and hook up the micro USB cable. Turn it on. May have to adjust the brightness just because it doesn't show well on the camera. Okay.
Nice. Okay, run.
Well, first of all, what you have to do is, depending on what you want on here, you have to go ahead and select it, and then it'll load it up in here. We're going to just type load star 8. And so it actually runs the 1541 disk drive firmware on here, so it's like 100% compatible, as opposed to like the SD2 IEC, which did a lot of like guessing, but some of them 100% compatible. But this will actually run code. Takes a moment here because it's done loading. I'll run it. Because it's running the actual firmware, it runs the same speed and everything.
All right.
All right. Thanks, Melissa.
Hold on. And then it goes ahead and loads it right off of there, whatever.
Yay! All right. 64, back to life.
Yeah, okay. Well, in order to speed through people, I'm gonna just leave it at that.
Yeah. No, I mean it was I remember it would take a long time to load stuff on the Commie 64.
Yeah.
All right. Well, maybe we'll come back to you at the end if you are running something. All right. Thank you,
more
Melissa.
retro stuff. Let's
Melissa 3D
go
print.
to Liz. Let's read what you got going on this week.
Hey, so I started working on a project with the Memento, where it's going to take a photo, send it up to OpenAI, have OpenAI describe the image, and then send it back. So I can do a demo where I take a photo of this wonderful Triceratops, and you can see there.
Okay.
Sending to OpenAI.
So it saves the image.
Yes, and then we have.
This is with Memento, the camera.
Yes.
Takes the open source camera takes. Yeah, this is a different approach for folks pay close attention. So you're taking a picture with the camera, and then it's sending the image and it's saying describe it.
Yes. So they just spit back for the Triceratops, a small yellow toy Triceratops dinosaur positioned on a flat surface. So I've been really impressed with how the prompts have been. I'll minimize.
I'm gonna. Is that what it was? That's exactly what it was.
That is what it was right there.
Oh wait, we'll try something different. Maybe that 8. What is that colorful 8 next to?
Oh yeah, this is like a anxiety thing. But let me see. Take a photo.
Okay, and then let's go to the.
And then I'll bring back up Moo.
Okay.
Colorful circular board game overlay of numbered spaces and instruction squares laid out on a flat surface. And then I did another one earlier, which was I had taken just as a test a pin that's on my bag, and it sent back oval-shaped pin with an illustration featuring iconic symbols of Boston, including a skyline silhouette, all set against a background blending night and sunset shades. The word Boston is prominently displayed on the bottom. Pin is resting on the staff shoulder, so it can read, which is cool.
That's pretty impressive.
Yeah, and then this is the prompt I'm using. Please describe what is in this image. The description should be in the style of alt text used on social media sites like Mastodon. Avoid talking about the quality of the image. Avoid talking about the background of the image. Only describe the main subject. So I know a lot of people like to kind of dunk on OpenAI, but if you really like tailor your prompts, you can get like really good results. So
this is a remake also, by the way, of a project by Matt Richardson, and his project from 12 years ago used Mechanical Turk. So it had people who you would be paying 50 cents, which is kind of a weird thing. You would send it to Amazon and they would distribute the task, and then like a few minutes later you get it. But it's amazing that you could do it all with OpenAI instantaneously.
So, with all this stuff, as always, there's like extremist opinions, like it's going to take over and kill us all, and it stole every artist's artwork. And then there's AI for, you took a picture of something you want to take a picture of, you're saying describe it, and it's bringing you back alt text, which could be used for vision impairment. It could be used for text to speech. It's your data, what's being sent there, and it's very specific, and it's running on an open source camera, and the only thing you're sending is the photo. There's no other metadata on it because it doesn't have a GPS in it. So this is a really good use. Sometimes, it's hard to, any tool could be used for that, but this is one of the, I think, fun uses. And we're documenting it all. We'll have a guide. Yeah,
this is super cool. Yeah, we have a couple other ideas of like prompts that you could use that can be like anomaly detection. Because we were talking about how, I saw a project where somebody had a camera pointed at their basement, and they just asked, like, they would upload the image every 20 minutes and say, hey, OpenAI, is there any, this is a picture of my basement. Is there anything weird going on in my basement? And it, they faked in some photos of it, like a flooded basement, and like it would detect and be like, yeah, your basement's flooded. So instead of having these complicated visual recognitions that would try to like identify things, you just kind of use the generic identification code of ChatGPT. It's kind of interesting.
Yeah, I was really excited about it. So
it looked great. Kind of freaky.
Yeah, good work. That's a really cool project.
Thank you.
Thanks, Liz.
Okay.
All right. Next up, we're going to go to Sun and Moon, and then we'll go to Mark and then DJ Devin. Take it away.
Hey, guys. How's it going? So I wanted to talk about the fashion show. Usually I come in and I show some hardware that I made. I did actually have some hardware, but in the interest of speed run, I am going to focus on just talking about the fashion show because you guys did want to see kind of what happened. You asked me to come back and talk about it.
Yeah.
So I'm going to share my screen and let me know if you guys can see that.
It has arrived.
Ding dong.
So this is just my Instagram. I wanted to start out with introducing some of the designers that we had on the show. I was obviously one of them, so I'm going to post a link to my Instagram and you can check out all the amazing designs that I like. The other person that we had, and I was honored to be, on the same stage as this person, Janet Hansen. If you don't know, she's made LED wearable coats for people like Daft Punk, Britney Spears, Katy Perry. Just makes some amazing, really high quality stuff. And like looking at the stitching, and she stitches it all by hand with so many pixels on an outfit. She also makes this really cool art that was up on the walls on display. So she's an awesome artist. Definitely check her out. The third designer we had was Enlighten. If you're not familiar, they work closely with Make Fashion, and Enlighten has their own brand of LED strips that are custom made for LED wearables, and they've got like a custom controller and custom batteries. They actually sent me one of their batteries that are laser etched, and they used OpenAI or ChatGPT-4 to generate, because they couldn't find my logo because I don't have one. So they just used AI to generate
That's cool.
a sun and moon
That's kind of cool.
logo with PCB traces.
That looks nice.
I love it. I was ecstatic when I saw that, and they laser etched it into a backlit battery. So that's actually the battery pack.
Nice.
Right? And you can put custom logos on it.
Do that.
Yeah, they make some amazing stuff. I was going to show, there's a video. I'm not going to play the whole thing, but I can post.
Yeah, you can put a link in the chat.
Yeah, I'll post the link there. But real quick, I did want to show like a couple pictures, if that's all right.
Yeah, go for it.
I don't know if it's sharing. I don't see.
I only see the video screen, the YouTube screen. So
I
need to bring in another
window. Present again. Share screen. Window. Oh, it's by window. I want entire screen. Apologies there. All right. Can you guys see that now?
Yeah.
So this is like an LED parasol that I made for a client, and one of the chain gem outfits. Another chain gem outfit with the poi that I did show on a previous show and tell. And those are open source poi, and we're going to be posting the hardware for that shortly. More chain gems with infinity goggles, infinity mirror goggles on the top. This is a staff that I also talked about in a previous show and tell that's also open source. It does POV if you're spinning it, but you can't really tell when, they're still images. This is like my favorite thing I've ever made. It was a full spandex bodysuit covered in LED pixels.
That's great.
And it's just an amazing, I really like this suit. This was the hooded vest that I had also shown on a previous, cool. So you guys have seen that.
With the mapping,
Yeah. And then parasol again, more chain gems. I bought a sewing machine just for this event and tried like making a scarf for the first time. So that was like literally the first scarf that I had ever, like fabric project really, that I had done. There's another version of the scarf there that you can see.
Oh, cool.
And then these models, like I had zero budget. So this is like my friend from high school and like his friend. So these people went to our high school. Like the previous model, I like messaged this girl on Instagram the day before and was like, hey, do you want to be in my show? And she was like, yeah, let's do it. So really awesome.
Okay.
Yeah, I think that's
These are fantastic.
Love it. Great photos too.
it's like a very advanced Burning Man and cyberpunk, and like you could tell that the fashion and the tech are finally able to meet. It's not just clunky. It's like there's a lot of the stuff. It's like that looks good to wear anytime.
Yeah,
and you can.
Yeah, we're definitely getting to this cyberpunk future we've been promised.
We're trying to get with our brand away from just festival and Burning Man looks and create things that you could wear to, black tie events.
Yeah.
I don't know if it's going to work out, but that's what I'm trying to accomplish here.
Rainbow time.
Outstanding.
Okay.
Yeah.
All right.
Well, thank you.
There's so much stuff. Feel free to come by and pick one and come by and show parts of it or whatever.
Yeah, I had stuff to show. I'll do it next week.
Yeah, we've been doing this for 15 years. Yeah. Come on by, and thanks, because getting the word out and showing that other people can come along. The more LED in electronic fashion, the more LED in electronic fashion you get. Yeah. It helps push the medium quite a bit. So thank you so much for coming by and sharing this.
Thank you, and congrats on the new logo.
Yeah, good stuff.
Okay.
All right, we're gonna go to Mark, then DJ Devin, and nanographs. We can keep it to a couple minutes each. We'll get to everybody. Take it away, Mark.
Hello.
Hello.
So no fancy LEDs for me this week, but I had seen a lot of the releases on the USB HID human interface devices that have been coming out in CircuitPython. And around the same time, I got a VR helmet and started playing with Microsoft Flight Sim, which is what you're seeing on the upper left. And then I was looking up, because people have these super fancy rigs that cost thousands and thousands of dollars, getting close to actual airplanes. So I wanted to see, it's like, I can buy a replica. This is one of two screens of a G1000 glass cockpit, but it was like almost $1,000 to purchase this. And I was like, well, I can start doing this for a lot cheaper. And specifically this button in the lower right-hand corner, which is used to set your flight plan, which I can briefly. So if I bring up the flight plan, I was able to find these dual concentric rotary encoders. So it's actually two rings, the bottom one and the top, which simulates, I can't actually zoom in closer, but simulates the two rings on the actual control. And then I found there's actually open source software called MobiFlight, which is specifically meant to map devices, whether they're joysticks or input or output, into various flight sims, Microsoft Flight Sim, XSim. So I was able to then create a device descriptor just for a very simple joystick. This is actually, if you turn it one direction, it's a one button press. The other direction is a different button press. And then the top actually presses in two. So then you can start programming your actual flight plan a lot easier than if you were trying to just move this with the mouse. And it doesn't cost $800.
Nice. Please write this up on the playground. This would be so cool. I'd love to hear about this, because I know people love making interfaces for flight sims. And yeah, you can go like pretty expensive, but some people just want to make their own thing.
Exactly. And that's how I got into it. MobiFlight actually has some Arduino compatible interfaces, but it's all serial communication. So I'm like, there's no way that this can't.
Yeah, I like that this is just like HID, CircuitPython, really easy, no IDE required.
Yeah, and super easy, and it's on my list to write up on Playground. I just haven't had the time, and I was trying to write it up and I actually broke Playground. I'm sorry.
Good job.
Good.
It's open beta, so please continue to break it.
Yeah,
that's how we fix it.
And then let us know.
Support was very fast, and they got back to me right away. And I don't know what I did, but it's working again for me.
Yay!
Good work. All right. Well, thanks so much. This is awesome.
You playgrounded too hard.
There was a lot of people making, accessories for whatever virtual or sim they were doing. There was like a trucking one, and this is cool to see this for airplanes. Very cool.
And CircuitPython's super quick to edit it in. So
love it.
All right.
Thanks, Mark. Very cool.
All right, we're going to go to DJ Devin, and then Nanographs can keep it to 2.5 minutes each. We can get both of you in. Take it away.
Yes, please. Somebody should send Mark I broke the playground little button like he does for as seen on
I broke
show and tell. Yeah,
little kid falling off a swing or something like that.
So this one is a display that I've been working on. These are display adapter boards. Focus. This one is using a feather, and I would like to thank Gamblor for God, how do I put this? A little write-up that he did in Git on how to share a spy bus. And there are tutorials and there are learn guides about how to do it, but he just made it sound so practically easy to implement. And so I was able to implement spy bus sharing on a Qt Py so that it shares a touch controller, touch display, and SD card, and takes up every pin. Normally they would take up like nine pins, but this only takes up 3. And I don't have a display code running on there, but I assure you it works.
Okay.
Just like that one. So that's just an update of my my progress with the display code, and that's all I have to share. Oh yeah, I'm also working on making a 3D case for the Memento.
Oh, good.
And then I found these tiny little flip up lids.
Ooh.
For a lens protector, because the Memento does not have a lens protector. So with 3D printing, should be able to stick that right on and then have a lens cover.
All right.
That was just one thing I noticed about the Memento is there's no like lens guard.
Yeah, we wanted folks,
there's an enclosure. And stuff.
Yeah, we wanted folks to also experiment with enclosures and all that. It's building your own camera. So yeah, share that too. Come back, show it off.
I will design a Memento enclosure. Thank you.
All right, thanks. See you next week.
All right. Nanographs, play us out. Take it away.
Yeah. Let me just get the screen share going here if you want to show that. So we're in front of a Jayy 6400 right now, 1980s SEM. A few weeks ago, not last week, the week before, we did some live streaming. We put some diatoms in the microscope. It was back when we had the focused ion beam, and we cut the diatoms open with the focused ion beam.
And then we put some Adafruit Feather in there.
So I'll show one more diatom whole picture. So we really just went in there and sliced away at it. And we also found one spiky boy. We got the spiky ones. So I'll show you what we got in the microscope right now. We have an AMG 8833. This was something that we cut open when it was inside of the fib. So we're looking at the thermal. So
this is an infrared thermal camera sensor. It's got 64 by 64 pixels.
8 by 8.
Oh, 8 by 8.
Yeah,
8 by 8.
Yeah.
All right, cool. And you can
so
see
we're zooming in on it right now. Yeah. So each one of these arrays of 6 paddles makes up 1 pixel, and these paddles are just they just have a bunch of wires running through them. So what we did in the fib is we put this rectangular hole in it. Let me just move the stage a little bit here. Kind of center that up a little bit. So we put this rectangular hole in it so we can see a cross section of just how thin these paddles are. And then you can increase the contrast here so we can see that there's actually there is something behind it, but there's a large cavity behind each one of these paddles so that you can thermally isolate it. So we kind of see that this wire snakes through and just goes back and forth, back and forth, back and forth across the wire. And so they just detect the resistance change in the wire to figure out how warm or cold each one of the pixels is. And you can see a couple of areas because it's a focused ion beam. Whenever the beam stopped for some reason, we just blew random little holes.
Yeah.
Sample, boop, boop. Yep. Yeah. So this sample is I've had it for a while. We've only imaged under SEM, but being able to just go in there and very precisely slice one rectangular hole, that's just the power of focused.
Wow, it's so fast too. Amazing.
Yeah. And so you can see some other parts of the die, and the die that's up here, kind of in the top of the frame right now, that's the control die. So that's what you actually digitally interface with. And there's just a couple of capacitors in the right corner there. That's all inside this one package.
Outstanding. One thing we're going to bounce in a second because we're going to do Ask an Engineer. But if and when you're ready, because we're talking over email, maybe we can coordinate and figure out what folks want to see.
Yeah, absolutely.
Some lead time. And then we can, promote it, and that way folks can see the thing. Like when we do the great search on Sundays, it's I'd really like to find the following part on DigiKey. You're in the same business now, except for you're doing it optically. It's that part.
We're joining you in the great hunt, though, as we work on getting our hardware ready to sell as well. So
yeah. So let folks in the chat have some requests, and then also if there, or maybe you can even say, hey, here's 4 different things we're thinking of showing off next week.
Yeah, that's exactly what we did. We just kind of took out all the memes that you had sent us previously. We're like, okay, what do we want to slice open? So we also sliced open a MEMS microphone. So we were able to see like the 2 different layers of the MEMS microphone. So this is the top layer, and then that has holes in it, and then the bottom layer is solid. So those moving further, closer together, are detects to change capacitively. So
very cool. Yeah. All right. Well, keep coming by each week, and if you know what you're going to show in advance, let us know, and we'll get the word out in all the social media places too, so folks can see this. All electronics are not magical; they're here. You can see them. Just
right? Yeah. What a great image of a microphone.
This is great.
Love it.
Yeah, you can see the hole I put it in the top left corner there. So anyways, you all have a good evening.
Yes,
thanks so much, and see you next week.
Keep it small.
All right, everybody, that's our show and tell for the week. I think we have the only live microscope.
LED art and microscope.
There's a lot going on.
Yeah.
So we'll see everybody next week, every single week, Wednesday, 7:30 p.m. Eastern time. We will be doing show and tell in just a minute. Thank you so much for making this the best half an hour of the week every single week. See you later.